Hello everyone, this is Mr. Fugay, and for this video today we're going to talk about how to graph and create angles in standard position. Before we start going through the notes, just notice on the right hand side here I have this applet. If you click on this button right here in the center, my hope is that it's going to open up the applet that we'll be using in this video, and we can move it and work with it and do different things with it as we're going through the video. If it's not working, you can click on this hyperlink right up here. It will open up GeoGebra on the web, which should work for you so you can follow along and use this tool to help you as you're working through this lesson. So we'll come to that in a few minutes, but let's go ahead and get started. Oh, notice it's already doing some things here. Up there, it's gone. All right. So what do we mean by angles in standard position? So we're still talking about angles that are on the coordinate plane, but in this case, they are drawn in what we call standard position. And by definition of that, an angle is considered to be standard position on the coordinate plane if its vertex is at the origin. And we've seen that with some problems already. And the other thing that we know is its initial side, the first side that we would draw of the angle, is along the positive x-axis. Now, I have a few drawings down here, and I'll talk about them specifically in a minute, but what I want to do is highlight in green what I mean by initial side. Notice in all of these examples, all 6 of these examples, the green line that I'm currently drawing on the screen is representing the initial side of the angle. Okay. Also notice that the angle itself that is in blue and or red is at the origin. So this takes care of all of the definitions that we need to. So essentially what's happening here, and I'll look at the applet now, is what you're looking at right now is you're looking at the initial side on screen, and when I click the slider, it's going to create that second angle. So you can see, for example, and let me make that a little bit bigger so you can see it easier. So when I go to make it, you can see that it's just rotating around to whatever angle I wanted. So there's a 45 degree, there's 146 degrees, and so on and so forth. Now, one thing that is noticed on here, as you might see, is the ones in blue are all being rotated in a counterclockwise motion. So that's going against a traditional clock that we look at, not a digital clock, of course, ones with hands on it. So it's moving in the counterclockwise motion, and we're going to say that these angles will have a positive measure. And this is how we've been measuring angles really all along. So something to keep in mind. But now, what we have to also consider is that angles in standard position can also be rotated in a clockwise motion, and in that example they will have a negative measure. So if you go over to the applet again, notice we have a positive orientation checked off, so when I click slide me, it'll create that angle for us no matter where we are, but notice it's moving in a counterclockwise motion. But if I go to a negative orientation, now look how the angle is being created instead. Okay, so we'll talk about how we measure angles with that in just a few seconds. But keep that in mind when we're measuring positive versus negative angles. Now, let's talk about the actual measures themselves, because how do we measure angles on the coordinate plane? So first off, we say the angle in standard position is said to lie in whatever quadrant its terminal side is located. So for example, acute angles, which we know are angles that are between 0 and 90 degrees, acute angles are always going to be in quadrant 1, since they always are measuring between 0 and 90 degrees. So let's do that, 0 to 90 degrees. But conversely, as we've talked about, another term we learned in this course is obtuse angles. So obtuse angles are going to be in quadrant 2, and that's because they measure angles between 90 and 180 degrees. Notice I'm not saying they are 90 or they are 180 because they're between. We had special names for 90-degree angles and 180-degree angles in the geometry portion of the course. What we're going to call those angles now, angles that are in positions that have their terminal side on the x or the y axis. So that would be 0, 90, 180, or 270. Let's go to the applet to show you what that means. Okay, let's go to positive orientation, and let's go ahead and make a 90-degree angle. It's 92, but close enough. There's 90. There's not going to let me do 180, but it's close to 180. 180, and then right there is 270. I got 270 on the nose. Those angles that are touching the quadrants, we're going to call them quadrantal angles. And that's because they lie in between the quadrants, so they don't have a specific orientation from that. So let's look at an example of how we can measure these out. And until you have a good number sense of how angles work, you can use the applet as you want to help you out with things. So for example, in this first example, we have an angle that's been rotated about halfway through quadrant 1. So I'm going to take the applet here. If you take it by this gray box, you can slide it along with us. Oh, it may not work. And if that's, oh, there we go. It's working now. If you're having trouble with it, like I said, you can always just scroll back up. So let me get them both on screen. So I want to measure something that's like halfway through quadrant 1, and I'm looking for just a ballpark. So you can see, I know that's really short, but you can see the ID here that this is going to be 49 degrees, which I would even argue it's probably more like 45 degrees. If you say 49 though, it's fine. This is also going to be in quadrant 1. That would be the first section here between 0 and 90. My second angle in letter B, that is in quadrant number 2, because it lies between in the upper left-hand corner of the screen. If I use the slider, I'll say it's about halfway between quadrants, 90 and 180, I should say. So it's about halfway between 90 and 180. Do your best estimate for this, but I'm going to argue it's about 135, which is exactly in the middle. 45 degrees is exactly between, by the way, because each quadrant is 90 degrees. So that's where I'm getting these numbers from. Letter C is going to be in quadrant number 3 because it is in the bottom left-hand corner. Same thing as before. So we start with 180. If we add 45 to it, that should take us to about 225 or so. So you can see this angle is directly between the 90 and the 180, I should say, and the 270. So we're going to go ahead and we're going to call this angle 215, I believe. I'm sorry, 225. 225. That's exactly between. And then last but not least, quadrant number 4, the last example, use the Roman numerals IV for that. In quadrant number 4, we're going to be between 270 and 360. So directly in the middle of that is going to be 315 degrees. So use this to help you out in terms of trying to draw these, especially if you're not comfortable yet with determining angles just by their looks. So let's have you try that yourself. So on these next examples, I'll do the first two. This is draw the given angle in standard position. So the first one's 136 degrees. So if I go ahead, I'm going to create something that looks to be about 136. Let's see, I got 135 right there. Close enough. So let's go ahead and let's draw a sketch of that. So there it is. So let's do my angle in red here. Okay, just like that. And then the angle moves like this. So that's going to be 136 degrees. The next one is going to be negative 62. So we're going to need to switch to a negative orientation. Let's go ahead and let's move it negative 60 right there, about 62. So when I go ahead and draw this, again, we'll draw our blank coordinate plane. We use the red, a different color. That's probably going to be a good idea. So it looks to be maybe about that. And that's going to be negative 62 degrees. So go ahead and pause this video at this point, and I would like you to try letters C and D. Feel free again to use this drawing on the right or this applet on the right to help you if you're struggling with what the angle should look like. Guys, welcome back. Here are the final two examples. If you use the applet to help you, you should have drawings very similar to this. So I have the angle 150, which was rotated to counterclockwise motion to be about here. I made it closer to 180 than it was to 90 because 150 is only 30 degrees away from that. And then last one, we have negative 210. So 210 would go here because that's negative 180 where my mouse is. And then it would move an additional 30 degrees. One thing I want you to notice with these two examples is even though these two angles have different measures, notice that your drawing of the initial side, which is on the positive x-axis, and the terminal side, which was the second side that you drew, are both in the exact same position. And we have a special name for this pair of angles. So 150 and negative 210 have a unique example that we are going to call, whoops, where did my notes go? There we go. We're going to call them coterminal angles. So coterminal angles are angles who share the same initial side and the same terminal side, but are named differently. So the negative 210 versus the 150, you rotated them differently. So that's the reason why they have a different label, even though they look the same. So in order to find coterminal angles without drawing them, you are going to add or subtract 360 degrees. And the reason why that is a full rotation around the coordinate plane. And we'll look at a drawing of that in a minute. So 360 degrees is a full rotation, so that's the reason why the angles would look the same. If I go over here to my applet, let's go ahead and let's look at a positive angle here. And I'm going to measure this one at 151 degrees. There it is. But what if I rotate it around a second time and put it in the exact same position? You'll see that we get an angle at about 508. So all I would do to figure this out is, you can see I can rotate. Let me make the angle smaller here. We can keep rotating and rotating, and you see that you're just making the same angles between 0 and 360, even though we have these much higher numbers. Same position, different measurements. And here are 3 examples for your notes that are already written in. You'll see that the first one is standard position because it's 45 degrees. It just rotates in quadrant 1. For the second one, we're going to rotate at 45, but then we're going to rotate an entire additional 360. That would give me an angle measure of 405. But since 405 minus 360 is 45, that's the reason we can say these are coterminal. And likewise, if we go in the opposite direction, so we go in a negative direction, this angle is going to be negative 315. But if I add 360 to it, we're going to get 45. So there's an example of 3 angles that look exactly the same, but all have different measurements. So let's try this out. So in example 2, I'm going to do letters A and C with you, and then I'll have you pause to try the others. We have 75 degrees. They said find one positive and one negative angle that are coterminal. So I'm going to take my 75 degrees, and I'm going to add 360 degrees to it. And I'm going to take my 75 and subtract 360 from it. And in both of these examples, when I add them up, we get an angle of 435 degrees, and then we get negative 285 degrees. So these 2 angles are going to be exactly the same. All 3 of these angles, I should say, are going to be exactly the same, but notice they have different measures. Now, in a larger example like 410, we'll go ahead and we'll subtract that 360 to get it as a smaller number. So in this case, we're going to get 50 as our answer. But if I were to now go back and add 360, I would get another positive angle. So one thing we can do is, since 50 and 410 are the exact same angle, I'm going to use the number 50 now and subtract 360 from it. And when I do that, I get negative 310. So there we are. There are 3 angles, the 410, the original, 50 degrees, and then the negative 310, that are all going to be coterminal with each other. They look the same, but will have different measures. So one more pause on this video. I'm going to have you go ahead and pause for letters B and D. Try those on your own. And then lastly, a little bit of a challenge here we'll go over at the end. Try this you-try problem. Identify the angle that is not coterminal with the others. So pause this video right now, and then we'll take a look at them together in a moment. Welcome back. Here's letter B and D. For B, I took the negative 200 and I first added 360 to it. I got 160 degrees. There's my positive angle. I took negative 200 and I subtracted 360, so I rotated it the other way around and I got negative 560. So there are my 2 answers. For the 860, because the number is so big, we're going to have to subtract 360 multiple times in order for us to get down to a negative answer. So first things first, I took 860 minus 360 and I got 500. Then I took the new number 500, subtracted another 360 from it to get 140. So we're just subtracting rotations here. And then we took 140 finally, subtracted 360 to get my negative 220, which then answers the question. So final question here was you try number 2. What I recommend doing is I started with the largest angle, which is 600. So I'm going to take 600 and I'm going to subtract 360 from it. And when I do that, I got 240 degrees is what I got, which then eliminates that choice. If I subtract another 360 from it, I get negative 120 degrees, so we eliminate that one. And last but not least, we subtract one final 360, and when I do that, I get negative 480. So starting with the number 600, I subtracted all the way. 180 is not coterminal with the others. So that will conclude this video on finding angles in standard position. I hope you found it helpful. And feel free to look back at any parts of this video that you might need to look at one other time. Thank you guys for watching.